Hello and welcome to Grade Up. Welcome to this ongoing series of the subject of theory of machines and vibrations. We have seen so far, we have covered the topics of simple mechanisms and their analysis, the velocity analysis, acceleration analysis, kinematic dynamic analysis, and we have also solved and we have also seen the questions that have appeared in the GATE examinations, in the recently concluded GATE examinations. So moving ahead on this course, the topic for today will be gears. This will be covered in two parts. So this will be part 1 of the gears. So let us begin. First of all, we need to know what are gears. Okay, and gears are used to transmit motion from one shaft to the another by direct contact. Okay, you need to look at this point of the direct contact because there are other transmission modes also, like the drives, like the belt drives, chain drives, and those rope drives, in which also the motion is transmitted from one shaft to the another, but in that direct contact is not there. So in the case of gears, one important or one unique thing is that it transmits motion by direct contact. Okay, so see, if these are two gears, that is, this is gear number 1 and this is gear number 2. If this is rotating at an angular velocity of omega 1 and having of radius r1, and this one is rotating at an angular velocity of omega 2 having radius r2, then at the point of contact, if you take this at the point of contact, say q, then this at point of contact q, the velocity given by body 1 will be equal to r1 omega 1, and by body 2 it will be r2 omega 2, because we know that v is equal to omega r in case of rolling. Okay, so as this point of contact is same or is unique for both the bodies, therefore the velocity of that point should be same. Either we consider it from body 1 or we consider it from body 2. So by this we have omega 1 r1 must be equal to omega 2 r2. Okay, or omega 1 by omega 2, if we take the ratios, we will get this as r2 by r1. And since once a body has been designed or it has been manufactured, this r1 and r2 is not going to change, means this ratio is a constant. So eventually this omega 1 by omega 2 also becomes constant. Okay, this is also constant. Then that means that slipping is not possible, because omega 1 by omega 2 is constant. That means slipping is not possible, because we have arrived at this by omega 1 r1 equal to omega 2 r2 and v1 equal to v2 and v1 equal to this and v2 equal to this by only of the case of pure rolling. That means slipping is not possible. And those drives in which slipping is not possible are known as positive drives. Okay, please remember, those drives in which slipping is not possible is known as positive drives, and those drives in which slipping is possible, they are known as negative drives. Okay, negative drives, the example, belt drives, rope drives, chain drives. I already told you that these drives are also used for the transmission of motion from one shaft to the another. First of all, they do it by indirect contact, and second one means that they are negative drives in which slipping occurs. Okay, and in those cases where slipping occurs, this omega 1 by omega 2 is not constant. Okay, this is not constant. So this is the negative drive, and gear drive is a positive drive, because in this slipping is not possible and the ratio of angular velocities of both the gears or both the bodies is constant. Okay, then we come on to the classification of gears. According to the The first criteria is according to the axis of the shafts connected. First, both the shafts are in parallel. If both the shafts are in parallel, the pure rolling motion, please remember this term, pure rolling motion, can be transmitted between two cylindrical surfaces in contact. Two cylindrical surfaces in contact. In that case, if the teeth are straight, because if there is a gear, it will have some teeth. If teeth are straight and parallel to the axis of rotation, it is known as a spur gear. S-P-U-R, spur gear. Okay, when the teeth are straight and parallel to the axis of rotation, it is known as spur gear. In this case, the axial thrust is equal to 0 because this is the axis and along this axis no force is going to act. So the axial thrust is equal to 0. But they are used for low power transmission at very low speeds. Why? Because there is instantaneous engagement and disengagement. The whole teeth of the gear will be engaged at once and will be disengaged at once. So due to this, due to the instantaneous engagement and disengagement, there will be impact stresses. So they are used for low power transmissions at very low speed. Okay. Then the next is, if the teeth are straight but they are inclined to the axis of rotation. If they are inclined to the axis of rotation, they are known as helical gears. If the teeth are straight and parallel to the axis of rotation, that were spur gear. But if the teeth are straight but inclined to the axis of rotation, they are known as helical gears. Okay, and helical gears are of two types. One is right-handed and other one is left-handed. See how it is. If this is the kind of two gears, if one is like this, then the other is like this. These are two kinds of opposite-handed helical gears. This is right-handed, this is left-handed. Okay, and opposite-handed helical gears must be in contact. This is the rule. You cannot have the engagement between a right-handed and a right-handed gear, helical gear. Not possible. Similar goes for the left-handed and left-handed. No. You must have opposite-handed gears, helical gears must be in contact for the motion to be transmitted. Right and left like this. Okay. In this case, the force will act towards this, and in this case the force will act towards this, and there will be some kind of, if you resolve it to this form, there will be some kind of axial thrust present. Okay, there will be some axial thrust present. How to minimize that? We will see how. But time being, you remember that axial thrust will be present in case of helical gears. It was absent in the case of spur gear, but present in the case of helical gears. Okay, and there is a gradual engagement. The teeth of the two mating gears do not engage and disengage at instant, but there is a gradual engagement and disengagement. So impact stresses are not present. Okay, this is one of the most important quality or most important property of this helical gear, that impact stresses are not present. There is a problem of this axial thrust, but we have a solution to this. How? See, to minimize the axial thrust, double helical gears are used. They are known as herringbone gears. This is a double helical gear. This was one part that we saw, but in this case there will be like this F force, there will be force like this. Okay, then if you resolve it into this kind of components, you will see that from the gear that will be mating above this, these radial force will be nullified, and these two axial forces cancel out each other. So the problem of axial thrust has been minimized. You cannot say that the axial thrust is now equal to 0, but it has been minimized. So to minimize the axial thrust, double helical gears or herringbone gears are used. So there is a question that in the case of helical gears, impact stresses are not present. Even if it is a single helical gear, impact stresses are not present. That is clear. But axial thrust exists. Axial thrust is present. And to minimize that axial thrust, what we do? We use double helical gears, also known as herringbone gears. Okay. So if it is a single helical gear, impact stresses will not be there, but axial thrust will be there. And to minimize that axial thrust, we use double helical gears known as herringbone gears. Okay. Then next, when both the axes are non-parallel but intersecting. In this case, the pure rolling motion cannot be transmitted by a cylindrical surface. The pure rolling motion can be transmitted by two conical surfaces. Please remember these terms, that which kind of surfaces are used for the transmission of pure rolling motion in case of which kind of orientation of shaft. If the shafts or the axis of the shafts are parallel, then cylindrical surfaces transmit helical pure rolling motion, and if axes are non-parallel but intersecting, then pure rolling motion is transmitted by conical surfaces, because these kind of questions appear in examination. Okay, so and these kind of gears are known as bevel gears. Okay, and bevel gears are again of two types: straight bevel gears and helical bevel gears. What is a straight bevel gear? Teeth are straight and parallel to the axis of rotation. That is known as a straight bevel gear, and they are again very less used, again due to the problem of impact stresses. And helical bevel gears are of two types, again right-handed and left-handed, and similar opposite-handed helical bevel gears must be in contact. And if they are of similar kind, if these two helical gears are present and if they are of similar, then omega 2 by omega 1 is equal to 1. That is known as, these kind of gears are known as MITRE, mitre gears. Okay, and if they are non-similar, then omega 1 by omega 2 will be constant, because it is a gear drive, positive drive, slipping not possible. So omega 2 by omega 1 will be constant, but it will not be equal to 1. So the velocity ratio will be same or will be equal to 1 in case of mitre gears. It will be constant in other cases, but it will not be equal to 1. Okay. Next, axes are neither parallel nor intersecting. Then in this case, the pure rolling is impossible. Pure rolling is impossible, but simple rolling, that is rotation plus sliding partial, is possible. Okay, is possible. And the generating line in this case is a skew line. It is neither parallel nor intersecting line. The gears of these kinds are known as spiral gears, also known as skew bevel gears. Okay, worm and worm wheel is a kind of example of this. This is a worm, this is a driving member, and this is a worm wheel, this is a driven member. And the most important application of this worm and worm wheel gear is they are used for very high speed reduction ratio. They are used for very high speed reduction ratio. So this is an example of a spiral gear or skew bevel gears. Okay. In this case, in the case of worm, the diameter of the worm is very small, and its helix angle is large. Whereas in case of worm wheel, the diameter is large, comparatively large compared to the worm, and the helix angle, or also known as the helical angle, is small. Okay, so please remember this, and they are used for very high speed reduction ratio. In this case also, the input motion is a rotation. Okay, and in this case the output motion is also a rotation. So both the motions are rotation, but this is the driving member, this is the driven member, and used for very high speed reduction ratio. Next, according to the type of gearing, that was according to the axis, the orientation of the axis, and now it is the classification based on the type of gearing. The first is external gearing. When the two gears mate externally, they are known as external gearing, okay, and the bigger gear in size is known as gear, and the gear is smaller in size is known as pinion. Very simple. Next is internal gearing. When the two gears mate internally, means one gear is internal to the other, then it is known as internal gearing, okay. In this case, the gear which is bigger in size is known as annular or ring, and the gear which is smaller in size is known as pinion, okay. Next comes the concept of compound gears. If more than one gears are mounted on the same shaft, then they are known as compound gears, okay. Please remember this. This will be very useful in the next topic of gear trains, that what are compound gears and how they are applied, okay. So please remember till then, the gears that are mounted on the same shaft are known as compound gears, and compound gears have the same speed, okay. And in general, in case of power transmission, the smaller bodies are made drivers. Why? Because we know this formula, that P, that power is equal to torque into omega, and for constant power, because if we require constant power to be transmitted, then omega for the smaller bodies or the drivers is more. So less torque is applied or less torque is required for the same power transmission. That's why in power transmissions, generally the smaller bodies are made drivers, okay. Next, we see some of the important gear terminologies, okay. This is the general figure of a gear. Let me tell you what are all the things that have been written one by one, okay. See, you can clearly see this kind of gear. This is the two gear teeth have been shown. This upper portion is known as the top land, first of all, okay. This width from here to here, this is known as face width, okay. Then the most important in this is this circle, that is known as a pitch circle, okay. It is a circle. It is an imaginary circle at which pure rolling motion is possible. That is known as a pitch circle, okay. Above it, the parallel circle which passes from the top portion of the gears of the face of the top land, that is known as addendum circle, okay. The gear which passes from this point, that is the bottom, that is known as the clearance circle, and the gear which passes from the lowest portion, that is known as a root or dedendum circle of the gear, okay. I will tell you the difference between clearance circle and the root and dedendum circle in the next class, when we will be doing about the base circle, when we will be talking about the interference part, okay. Till then, you just remember that clearance circle is above the dedendum or root circle, sorry, okay. So this is the order. If you go from top to the bottom, that first comes the addendum circle, then the pitch circle, then the clearance circle, and the root and dedendum circle. And the pitch circle is that imaginary circle along which the pure rolling motion is possible, okay. The portion of this side of the gear, of the teeth of the gear, which is above the pitch circle, is known as face, and below it is known as flank, okay. This length from the pitch circle to the addendum circle is known as addendum. From the pitch circle to the dedendum circle is known as dedendum, okay. The total depth is from the addendum circle to the dedendum circle, and the working depth is from the addendum circle to the clearance circle, okay. I hope these points are clear to you. Then what is a circular pitch? Circular pitch is the distance between two corresponding points on two gear teeth. If this is one point and the corresponding point on another gear is this, so this is the circular pitch, and that too measured along the pitch circle, okay. not to be measured along any other circle, measured only along the pitch circle. Then the tooth thickness, the thickness of this portion, that this plus this means this distance is tooth thickness, and the space between the gears, this is known as tooth space. So circular pitch can also be written as tooth thickness plus tooth space. Okay, this is the basic gear terminology. Then we see how the mating of the gears take place. See, if this is one, that is gear having a center at O1, and this is the gear 2, that is known as pinion, having the center at O2, then this is the point P, that is known as the pitch point, or this is the fixed point, and this is the point Q, that is the point of contact. This pitch point is not going to change, but as the motion of the gears takes place, this Q point will change, and this Q point will move along this line, that is known as the line of action. So the force will be acting towards this, and this PQ point will move towards along this line. Okay, this line, which is the common tangent at P, or the fixed line, the angle made by the line of action with this line, the common tangent, is known as pressure angle. Okay, and this line of action is also common normal at the point of contact Q. Okay, and for a pressure angle, there is a convention that pressure angle should not be greater than 20 to 22 degree. Okay, 20 to 22 degree, it cannot be greater than this, because there are some constraints we will see. Because this is just the basic lecture, I am telling you about the terminologies and get you familiar with the terms that are used in the gears. The main analysis of the gear will be done in the next class. Okay, so the pitch circle, I have already told you, imaginary circle in the gears where pure rolling motion is observed when the mating gears are transmitting power. Simple. Next, some important terms, that is circular pitch. I already told you what is the circular pitch, the distance between two corresponding points on two gears. Okay, if the pitch circle diameter is d and the number of teeth is t, then circular pitch is given by pi d by t. And for the two mating gears, the circular pitch must be equal. So pi d1 by t1 equal to pi d2 by t2, cancelling pi from both sides, we get d1 by t1 equal to d2 by t2. Okay, from this only comes the concept of the module, that the ratio of pitch circle diameter in mm to the number of teeth of gear is known as module. Please remember, this diameter is to be taken in mm, that is in millimeters. Okay, then diametral pitch, that was circular pitch, this is diametral pitch. Diametral pitch is the number of teeth of gear to the pitch circle diameter in inches, that is t by d inches. Okay, you see that circular pitch was pi d by t and diametral pitch is t by d. So if you multiply these two, that is pc into pd, the circular pitch into diametral pitch, you will get pi d by t into t by d. So this gets cancelled. So we are left with pc, that is circular pitch into diametral pitch, is equal to pi. This I have written here. Then tooth space minus the tooth thickness of the mating gear is known as backlash. Okay, we have seen that the tooth space is the, let me show you it once again. This is the tooth thickness, and this is the tooth space, sorry, this is the tooth space, and if another gear comes in from mating here, and the thickness of that gear, the tooth thickness of that gear, the tooth space minus this tooth thickness is known as backlash. And this is important because in case of that motion to be, when the motion is being transmitted, some heat will be generated. And as you know that by thermal expansion, when there is some heat generation is there, the teeth, the gears expand. And if this gear expands more than the, means the thickness of this gear increases more than the tooth space of this gear, of the mating gear, then there will be jamming of the gears. Okay, so backlash is provided to prevent jamming. The main purpose of providing backlash is to prevent jamming in case of expansion of gears due to heat. Okay. So this is all. This we have seen some of the basic terminologies that are used in a gear transmission, and we will see the real analysis of the gears in the next class. Till then, you can solve the questions as much as you can and download the GradeUp app. Solve the daily quizzes, the mock tests and all. And if you have any queries and any doubts, you can write to us and the app on the website. Till then, keep learning, keep growing. See you in the next class. Till then, thank you. Bye.